Let's look at some energy density problems, okay? The first concept really, and I see two types of problems with this. I see heat, like we heat water up, or we run thermal power plants. Let's just look at the first concept, right? The first concept is just how do we deal with energy density, okay? And the idea is this, right? If we take something like petrol, which is, we call it gasoline, right? If we take gasoline, we know that 1 kilogram has a specific energy of 45 megajoules per kilogram, okay? So 1 kilogram has an energy of, if we burn it, or release that energy of 45 times 10 to the 6th joules, okay? So then the question is, how much mass do you need to create or release 100 kilojoules of energy, right? So there's kind of a formula, but it's not really in the data packet, so we just have to like scratch our head. But this is the idea, right? The energy is the mass times the specific energy, okay? It's a bit like, phase changes or something like that, right? So in this case, our energy is the mass times the specific energy. So therefore, the mass is going to be the energy we need divided by the specific energy. So that's going to be our 100 kilojoules is 100 times 10 to the third joules. And then we're going to divide by, and since it's petrol, we'll divide by 45 times 10 to the 6th. And this is joules per kilogram. And the 10 to the 6th is because it's mega, right? Megajoules. Sorry. 100 E3 divided by 45 E6. And this ends up being, the mass is 0.00, and then it's all twos, right? It's 2 bar kilograms, which we want grams, right? So grams would be 2.22 grams. Okay, so that's the basic idea of energy density. So look at what there is. Coal, they'll have to tell you. And obviously wood is probably, also approximate. Notice that nuclear is 8 times 10 to the 7th megajoules, right? So really the specific energy of uranium is, and then you see, by the way, widely varying numbers for this, right? But the specific energy would be actually 8 times 10 to the 13th joules per kilogram for uranium. And that's because this is 10 to the 7th, and then it's already 10 to the 6th, so it's a total of 10 to the 13th because of the way exponents work. Okay, so that's for uranium. A little more energy density than these guys, right? All right, that's enough for now for that.